Good morning, everyone. Welcome back to my YouTube channel. Thank you so much for the support so far. I do not take it for granted. I am entirely grateful. All right, so I decided to try using A4 paper for a while, and possibly this video and some videos to come you are going to see that I'm using A4 paper and pen. So I want us to see how it goes, if it's cool, if we get the message, if we understand it. Please let me know what you think about this. All right, so today we'll be learning about homolytic and heterolytic fission. Homolytic and heterolytic fission. So I would describe what it is and try as much as possible to make us understand it. So for homolytic fission, please just follow me. I'll try as much as possible to make it work. Homolytic fission. So it is a type of fission between two atoms. So we have a particular compound that contains two atoms, and both of them have similar electronegativity. So the electronegativity of the atom A making up the compound and the atom B also making up the compound is similar. So when they cleave, when there is cleavage or fission, then the two atoms carry their respective atoms. So because a bond is formed by two atoms, by two electrons, a bond is formed between two atoms by two electrons. So when you have a bond, that means there is a pair of electrons. It might be that a particular atom donated the two, or that um, one atom donated one and the other also donated one. They might share, or then there will be a transfer. So in the case of homolytic fission, we have two atoms that have the same electronegativity, and the electron pair between them, that is the bond between them, is shared equally, and each atom carries an unpaired electron after this fission, and when they have that unpaired electron, they are known as radicals. So this is what I'm saying two atoms, let's say A B, two atoms A B, you know, meaning that this particular bond has two electrons, one from A and one from B. So something like this. So both of them share these two electrons, and both of them have similar electronegativity. So when they cleave, when there is fission between those two, they would have they would become radicals. So we have something like this, that when they cleave would have A being a radical, also B being a radical. So both of them, these two, are called radicals. So for instance, it happens between atoms with the same electronegativity, like I said. So let's take for example, we have chlorine molecule. So when chlorine molecule undergoes homolytic fission, we have chlorine radicals being formed. So that's what we have. Now, what are the things to note? Similar electronegativity, it leads to production of radicals. So what are radicals? Radicals are very reactive species. Because of the high reactivity that radicals have, they are unstable. You understand? They easily, quickly complete their reaction and form a stable product. So that's what we know as radical. Then we also have another thing to note is that homolytic fission is also known as radical fission. Homolytic fission is also known as radical fission. Also, another thing to note is that chemical reactions that are involving homolytic fission are known as free radical reactions. So I'm just saying all of this so that in case you see radical fission, you'll not be wondering what is this. It is still this same homolytic fission that we are talking about. So reactions, chemical reactions involving homolytic fission are also known as free radical reactions. So in summary, what I've said is homolytic fission is between two atoms of equal electronegativity values, and they would lead to this homolytic fission leads to the production of radicals. And I said that radicals are very reactive species and they are unstable. So homolytic fission is also known as radical fissions, and any chemical reaction like this involving homolytic fission is known as free radical reactions. This can be it can be instigated or initiated by light, by different things. You understand? So if it is instigated by light, then it is photolytic. You understand? All right. So we move to heterolytic fission. Heterolytic fission takes place between atoms of different electronegativity. So we have it takes place between atoms of different electronegativities. So and it involves the transfer of electrons. So unlike here where we have sharing of electrons between these two atoms, where one brings contributes its own electron and another contributes its own electron. Here we have transfer of electrons between two between the more electronegativity atom and another one that is not so electronegative. So we have they have two different electronegativity values. So what I'm trying to say is that if you have an atom AB, one will be slightly electronegative than the other. So the one that is electronegative, let's say B is the most electronegative, it would, you know, it will draw electron to itself, and so we would have um, something like this where A becomes positively charged and B becomes negatively charged. So unlike this that leads to the production of radicals, this leads to the formation of production of it leads to the formation of charged species or ions. So these are the charged species or ions. So we have this to be positively charged and this to be negatively charged. So like I explained, it happens between atoms with different electronegativities. So for instance, let's say we have um, hydrochloric acid. Here chlorine is more electronegative than hydrogen. So what happens after heterolytic fission is that chlorine will draw the electrons, these two electrons, to itself. And so hydrogen will be left with a positive charge and chlorine now has the electron. So it will be left with a negative charge. So these are the charged species or ions that are formed from this reaction. I hope that we understand. So here B is more electronegative than A. Here chlorine is more electronegative than hydrogen. And this particular chlorine is said to be electron rich. because apparently it has gotten all the electrons for itself. While hydrogen is to be electron deficient, said to be electron deficient. So that's what we have for homolytic fission and heterolytic fission. So homolytic fission forms radicals similar electronegativity, and it's also called free radical reaction, while heterolytic fission happens to form charged species. You understand? Charged species, it happens between two atoms of different electronegativity values. So I hope that this video was helpful. If it was, let me know in the comment section if you understand. If you have questions, let me know. If there's any chemistry topic you want us to treat soon, also let me know. I'll be willing to help. All right, thank you.